Today we'll be looking at similar polygons. If you remember the last semester, we looked at congruent polygons before Christmas break. Congruent polygons, all the angles were congruent and all the sides were congruent. And you can see these top two examples here. In similar polygons, you can see that the shape is the same, but the size of each side is not the same. So the definition of similar polygons is two figures that have the same shape, but not the same size. So same shape, but not same size. So you can think of some equilateral triangles. So if you have this equilateral triangle, it would be similar to this equilateral triangle because the shape is the same, but not the size. Circles. This little circle would be similar to that bigger circle because the shape is once again the same, but not the size. So same shape, but not same size for similar polygons. In similar figures, the sides are proportional and the angles are congruent. So all corresponding angles are going to be congruent. So this angle here will be congruent to this angle here. This angle will be congruent to this angle. And finally, this top angle will be congruent to this angle. And when I say sides are proportional, I mean this side corresponding to this side. So 6 over 3 will equal to 6 over 3. Well, that's obvious because it's the same number. Will equal to 10 over 5. And if you check, each of these fractions reduces down to 2, so they are all proportional. Therefore, these two triangles would be similar. Oftentimes, all the fractions will be slightly different and reduced down to the same, so you're not always going to see 6 over 3 and 6 over 3. Now, the ratio of the lengths of corresponding sides is the similarity ratio. So you can say our similarity ratio is 6 to 3 or 6 over 3. And of course, you'll want to reduce that. 6 to 3 becomes 2 colon 1. 6 over 3 becomes 2 over 1. So when I ask for similarity ratio, that's what it's looking for. So the important things to remember here for similar figures is that your sides will always be proportional and that the angles will always be congruent. All right, so let's find the similarity ratio between the first and the second polygon. So this side of 4 corresponds to this side of 6. So 4 to 6, and that of course reduces down to 2 to 3 because 2 goes into 4 twice, 2 goes into 6 3 times. So 2 to 3 like that, or you can write it as a fraction, of course. If you had checked with 8 and 12, you would have seen that the answer would have come out to be the same as well because 4 goes into 8 twice, 4 goes into 12 3 times. Now let's talk about scale factor. The scale factor of two similar polygons is the ratio that will transform the first polygon, so the one you begin with, the old polygon in other words, to the second one, the new polygon. Scale factor is written as new side of a polygon over the old side of the corresponding polygon. New over old is a great way to remember it. While you're copying this down, let me show you a few examples of ways that we could word this. Let's say that we're going from triangle ABC to triangle DEF. So here's triangle ABC, and here's triangle DEF. I could say, okay, let's say that this side is 4 and this side is 7. Okay, and I'm going to tell you right now that triangle ABC is similar, remember that squiggly line means similar, to triangle DEF. This is what we call a similarity statement, very similar to congruent statement, except for it has a similar sign. So if I'm going from triangle ABC to triangle DEF, I'm beginning at ABC, so that's my old triangle, and I'm ending at triangle DEF. That's my new triangle. So the new side is 7 over 4. So that would be my scale factor right there. Now, if I went from triangle DEF to triangle ABC, the scale factor would change because now DEF would be my old one I'm going to my new triangle ABC, so 4 over 7 would be my new scale factor. When it comes to scale factor, it's very important that you put the new over the old, okay? And don't forget that this is what a similarity statement is as well. You'll see questions like that on your homework. So in other words, angle A will still be congruent to angle D, B will be congruent to E, C will be congruent to F, AB will be proportional to DE, and BC proportional to EF, AC proportional to DF. All right, so an example of scale factor is Hot Wheels. If you ever played with those as a kid, 1/64th was a scale factor. In other words, each measurement of the real car was 64 times bigger than the toy car. All right, so given the figures are similar, find the scale factor from the first figure to the second. So we're going from the first to the second. So the new one is the second figure, so 5 over 2. Does that reduce? No, so that's your scale factor. Given these figures are similar, find the scale factor from the first figure to the second. I want you to quickly try this out on your own. It shouldn't take you very long. From the first to the second. All right, so from first to second, so second is new, so 6 over 27. And that, of course, reduces because 3 goes into 6 twice. 3 goes into 27 9 times, so 2 over 9. All right, this is where we get into it a little more. Like it's a little more difficult, where we actually have to find for missing sides, setting up proportions. So it tells me in the instructions that the figures are similar. So I know that these two triangles are similar to each other, so their sides are proportional. Now you might be tempted to say that 12 corresponds to 10, but if you notice, the 20-degree angle is here and the 20 is over here. So this is actually, it looks like it is reflected. So first off, what's Z going to be? Well, we know that the angles are congruent, so Z has to be 30 degrees. So that was easy enough. Now, let's try to find, let's say X first. So if we start in this triangle, we have 12. Okay, we know that's the side we have. What side corresponds to 12 on this triangle? Well, the 8 does. So what we want to look for first is two corresponding sides that have actual numbers and not letters in them. So 12 and 8 fit that criteria. So 12 over 8. Now, if you wanted to start from here and go to here, you could also do 8 over 12. It doesn't matter because it doesn't, even though it's asking for scale factor, it doesn't really tell me which figure is a new one. So let's define that real quick, actually, so we can give you a scale factor. Let's say that this is A prime and this is A. So we know that the new figure will be the prime. So 12 would be the new side over the old side, which is 8. So your scale factor reduced 12 over 8 becomes 3 over 2. All right, so let's go back to it. Sorry, we got off topic there. So first we look for two sides that are corresponding with numbers. So 12 over 8 equals to, well, if we're looking for x is in this triangle, so it's with the 12. So the x goes next to the 12 over the side that corresponds to x would be 10. Cross multiply. 12 times 10 is 120. 8 times x is 8x. Divide by 8. So x equals 15. All right, let's find y now. I'm going to still stay with the 12 over 8. I'm not going to change that. So 12 over 8 is going to equal to, well, what side corresponds to y? This 8 does, and it's with the 12. So 8 needs to go next to the 12 over y. Cross multiply. 12y equals 64. Divided by 12, so y equals, let's see here. If you type in 64 divided by 12 in your calculator, and you hit math enter, of course, you get 16 over 3. Remember, your calculator will reduce that fraction for you. So 16 over 3. Okay, I want you to pause the video and try this question out. All right, let's give it a try. So z is going to be 42, of course. Now, we want to find two sides that have numbers that correspond. So 5 and 14 fit that criteria. 5. So let's say, once again, this is A prime, this is A. So that gives you the scale factor is 5 over 14. New over old. So 5 over 14 equals, let's go with x first. So is the x with the 5 side or the 14? Well, it's with the 5, so it's going to go next to the 5. Over, what side corresponds to x? 20. Let's cross multiply. So 100 equals 14x. Divide by 14. Type in 100 divided by 14 in your calculator, hit math, enter, enter, and you'll get 50 over 7. Depending on what your teacher's asking for, you could get that or a fraction. Now let's solve for y. So we're going to still stay with 5 over 14. We're not going to change that number. 5 over 14 equals to, okay, so y is with the 14. So y needs to go next to the 14 at the bottom, and 4 will go on top. Cross multiply. 5y equals 14 times 4. 56 divided by 5. 56 divided by 5, math, enter in your calculator, gives you 56 over 5. And once again, depending on your teacher, you would also could get 11.2 there. All right, so 2 more problems and we'll be done here. Triangle ABC is similar to triangle DEF. The ratio of triangle ABC to triangle DEF is 5 to 3. If the perimeter of triangle ABC is 37 inches, find the perimeter of triangle DEF. So let's start by writing our ratio and setting an equal sign there. So ABC is with the 5. So ABC is with the 5. And DEF is with the 3. Perimeter of ABC is 37. So it gives me ABC's perimeter of 37. So ABC I established was on top. So 37 goes on top. And the perimeter of DEF will go on the bottom, which is X. Cross multiply. 5X equals, what's that, 111. Divide by 5. So once again, depending on your teacher, the perimeter will be 111 over 5 inches, or if they want a decimal, it's going to be 22.2 inches. This will always work for perimeter, just to set it up like this. All right, last question. A photographer enlarged a 5-inch by 8-inch photograph by a scale factor of 3. What is the dimensions of the enlarged photograph? Well, you just enlarge it by a scale factor of 3, so it's 3 times bigger. So instead of 5 inches, 5 times 3 is 15 inches. By 8 times 3 is 24 inches. All right, so please make sure you do your homework. If you're in on level, you have a worksheet to do tonight. If you're in K, you have some book work. So make sure you do your homework and get the practice you need. Thank you for watching. Have a great day.